Okay, so our next experiment class is distillation. So distillation is a physical process of separating liquids in mixture, and the basis of separation is boiling point difference. Okay, so if you have a mixture of liquid, okay, the distillation process actually involves two physical methods of separation. First is evaporation, followed by condensation. Okay, so when you heat the mixture, you are evaporating, you are increasing the temperature, so you increase the vapor pressure of the mixture. Okay, so the lower boiling point will evaporate first, and if you are going to cool it somewhere, that vapor will condense into a liquid, and you collect that. Okay, so in order for the vapor to become a liquid, we have to lower the temperature. Okay, so we use what you call a condenser. Okay, so the whole setup is what you call distilling apparatus. Okay, and there are two types of distillation. We have what you call simple distillation and fractional distillation. What's the difference? The fractional distillation is a multi-simple distillation setup class, no? And the product, okay, will have a higher purity compared to simple distillation. Okay, so in other words, in a simple distillation process, once you receive the distillate, it is not actually pure yet. You have to do the second round, the third round, the fourth round in order to increase the purity. So instead of doing that, scientists developed a glassware in which you can do multiple simple distillation in one setup by just introducing a fractionating column type of condenser. So you will notice a fractionating column because there is a coil like this. And every coil here, class, represents one simple distillation process. Okay? In a simple distillation, you only have this one here. Okay? You call this the condenser. Okay, so how are you going to set up a distillation experiment? So first, this is the condenser. This is the boiling flask where you are going to place your mixture, and you have the connector between the condenser and the boiling flask. You call this the adapter. Okay, and then you have the end of the condenser. Okay, wherein the condensed liquid will, emerge, no? And this is connected to a beaker which serves as a receiver for the distillate. Okay, so here to do the setup, you need the iron stand. Okay, and here we're going to use a mixture of methanol and butanol. Now, which one has a higher boiling point? Okay, of course the butanol, because it has a higher molecular weight, okay, compared to methanol. Okay, so we expect the methanol to come out first, followed by butanol. So to see whether there is a separation of the two, what you're going to do is you're going to plot the change in temperature of the thermometer versus the volume of distillate that is coming out from the condenser. Okay, and when you plot that, okay, you should be able to observe a zigzag, okay, profile. Okay, so what do you mean by that? Okay, so here you have the boiling flask. Okay, you place your mixture here, and you have the hot plate. Okay, so this is connected to the adapter, and here you're going to connect the thermometer. Okay, so boiling is liquid gas equilibrium. So you have the bulb of the thermometer should be at the intersection. So when you have the vapors coming out here, they are expected to condense here. So you have the condenser. So A condenser is composed of two glass tubing. This is where the vapor will liquefy. Outside here, you have the coolant, which is water. And there is an inlet, outlet. And you have the water inlet. That's how you set up the condenser, right? So the liquid will come out here. So you have the receiver, okay? So this is the simple distilling apparatus. If you're going to change it to fractional distillation, this portion here, before you insert the thermometer, we're going to introduce another column. We call this fractionating column. So there is a coil there, and you're going to connect the condenser there, okay? So your thermometer will be here, there, up, okay? So as you can see, okay, your vapor will pass through these several coils, and each one coil is equivalent to simple distillation. As if you remove this distillate, you add it again here. But you don't do that. You just prepare this in one setup. Okay? So you have the flask, you have the mixture. Okay? So this one will have high purity, high separation. And how are you going to detect that? You can detect that if you're going to plot temperature versus number of drops. Okay? So if we're going to plot this, okay, when you have liquid, okay, once the liquid starts to boil, of course, when you increase the temperature, when you heat the liquid, the temperature will increase because there is no equilibrium yet. Okay, but once the liquid starts to boil, there is equilibrium, and at equilibrium there is no change in temperature. So you call this the boiling point. Okay? So you will observe a plateau. And once the liquid is converted into a gas completely, there is no equilibrium. So this one will increase again. Like that. Okay? So you will observe a zigzag. Okay? Now if you start from the ice, if you have, let us say, ice here, of course you will have solid liquid equilibrium, liquid gas equilibrium, and then gas. So you will observe how many plateaus? 2 plateaus. But here we start with the liquid, so you will only observe one. So this one refers to the first component of the mixture, and the second one will be the second component of the mixture. So the first plateau is expected for the low boiling point component, which is methanol. The second one will be the high boiling point component, which is butanol. Right? But since we control the distillation in such a way that the butanol will not come out, then the one that will remain in the flask is your butanol. The one that is coming out will be your methanol. Right? So for simple distillation, because this is only one run, you might not be able to observe this sharp change in the plateau. In other words, you might be observing like that. And that is fine because this is an experimental result. But for fractional, okay, which undergoes several multi-simple distillation processes, we expect the profile to change. From here, maybe it should look like that. Although it's not very sharp, but there should be, the curve will be clearer, right? Meaning you have good separation of the two components, okay? So there. So we start with simple distillation. We are going to add 40 to 50 ml. So, okay, we'll approximate this using a beaker. So we have 50 ml here. Okay, there. It's 50 ml. Get the reading there. The 50. So here, 50 ml. Okay. So you have to be very careful because your mixture is flammable. So before you connect, we are going to add few drops of boiling stone. And the role of the boiling stone is to break down the formation of big bubbles, because big bubbles will cause the solution to explode. Okay, so it might break the flask. So if you add these porous stones, it will generate tiny bubbles, so the distillation will become smoother. Okay, so you can add 4 to 5 pieces of that one. That's enough. And then we are now ready to connect our condenser. But before we do that, okay, we have to attach this one first. Something to hold okay, so see to it that okay, you tighten the flask, no, to avoid if there is sudden explosion, it will not easily break. Okay, that's it. And we're going to connect the adapter. We have to be close to the sink. Okay, so this is our adapter. Okay, and our thermometer. Prevent stocking of the each component of the distilling apparatus flask. We add a lubricant. Okay, silicone. Huh? So you can turn this one, not to spread the silicone. Okay, this is to avoid the stocking of the tubing ends. Okay, so that is okay now, and then we are going to put our thermometer. So our thermometer is quite far. Okay, so we have this one class. Okay, connect. You have the thermometer set at the intersection. Now we're going to attach our condenser. So this is our condenser. Okay, so the water outlet should be up. The water inlet should be down. So the condenser should be positioned like this one. Okay. So we are going to lubricate again. Connection. Okay, there, and we're going to support this. So we're going to use I think that's okay now, plus, and then we're going to place our receiver here. Then place our adapter. So we have to lubricate this one again. Okay. So, well, it's very low, so we don't need this platform. So I think that's okay now. Let's turn this one a little bit. There. And then, before we start, we're going to add the water. Okay. So we're going to start to there. So we just have to wait for the mixture to boil. And what we're going to do is we're going to record the temperature every 20 drops. Okay? So every 1 ml. temperature of the hot plate, no? I raise the temperature because it will take a longer time for the hot plate to heat up. So now that it's boiling, okay, we can lower the temperature now. And take note that the boiling point of methanol is about 69, no? And your butanol is about, I think, 82, okay? 86. So let's see what you're going to do, class, okay? So what I'm doing now is you have to record the temperature every 20 drops or 1 ml. So I'm going to record it as ml. So if you notice your class, no, you already have the condensate. So that is about to there. Okay, it's going out already. See, so I'm going to count. Okay, 20 drops is 1 ml. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have to read. So this is 63. So 1 ml, 1 ml, 63 degrees. 14, 15, 16, 17, 18, 19, 20. So another ml, so that is still 63. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is still 63. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So still in the 63. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? So, maba ng konti, 62 degrees. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is 63 again. So that means pure is coming out. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, still 63. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So still 63. So we have to collect 35 ml plus. 9, 10. So we have collected 1, 2, 3, 14 ml already. 7, 8, 9. So this is now 64 degrees. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 64. So 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 20. Okay, so this is now 70. Okay, so this is the first data class. yung mayroong encircle, that is number 1. Tapos dito, number 2. Okay, and then sa likod, number 3. And then, number 4. Okay? So what you're going to do, you plot according to sa board, no? Temperature versus volume by 1 ml. Okay? So plot that and submit the profile. Okay? You have the data already, so you plot using Excel, y-axis temperature, x-axis volume of the distillate by 1 ml, no? So you have 1, 2, 3, 4. Or because you have a lot of data points, maybe you can plot it by 2 ml plus 2, 4, 6, 8, 10. Okay? So that's it, okay, for this experiment.